Yeah, okay. I'll be talking about emission modeling in Vissim. Let me see my crowd first. How many people have been involved in emission modeling before? Let me see. Great. So how many people have worked with external API like DLL in Vissim before? Okay, great. So at least we have people who will be familiar with what we are going to talk about. If you are not familiar, it's quite simplified, and I believe you will be able to catch it up very easily because I made it as simple as it can be made. Yeah. Okay, so basically a little bit of background in emission. We do know that, efforts in emission study is a global thing. It's not just a transportation thing. There are people who spend their entire career life working on emissions. There are people who spend a lot of man hours working on estimating emissions. But then, despite that, the studies that are done, for example, from the screen that you see, indicate that emission is actually still on the rise. So studies also show that if we look specifically into greenhouse gas emissions, 82% of these emissions are CO2. And then out of that, about 29% are attributed to transportation sector. Now, if you do a quick math, you will then see that transportation sector contribute about 23.8% of the greenhouse gas emissions. So there is also a study already done which indicate that despite transportation contributing about 23.8% of the emissions, the contribution from the transportation is, however, on a decline. And this could be attributed to, electric cars, better combustion engines, or just reduced VMTs on our roads. But now the big question is, how can we use simulation to help with estimating or analyzing emissions in our transportation projects? Can simulation help? Or as transportation folks continue estimating delay, travel time, level of service, can we have emissions as well as one of the standard MOEs that is generated when you want to study the impact of infrastructure development in a neighborhood, for example? Can you have emission as a standard MOE that can be put or generated when you want to study, for example, the impact of road diet, for example? So we want to see that in my presentation, I'm going to explain real quick and simply how you can work with an external API and create an emission DLL, and then apply this external API in Vissim, pretty straightforward, to do an emission network analysis. So maybe you can estimate the total amount of emission in the entire network, and then how to use it to identify emission hotspots as well. And then after that, how can you use it just to estimate emissions, say, of a particular vehicle type? For example, if you want to compare the emissions of CVs, AVs, or a mixed type of traffic, how can you do something like that? So how does the process work? I've explained that in brief, you will need to create a DLL, and then you link your DLL to each vehicle type in Vissim. And then every single simulation step, Vissim will send information, or DLL will get information from your network and from your vehicles, and then it will apply the model specification, which I will show shortly how to create the DLL, and then estimate the emission every single time step, and then it will send it back to Vissim, and then through evaluation, Vissim then produces or generates the emissions as an output for every single simulation step. If you do not want to generate it every single simulation step, you can then do an evaluation for an entire simulation, and then you have the emission generated for a single simulation run, in which the simulation time and the evaluation interval are the same. In that way, you just get the total emission at the end of the analysis or end of the simulation. So let's look at the first step. How do you execute, how do you create the DLL and use it in Vissim? First, for you to create the DLL, first thing first, you have to have parameters. Parameters will be like your variables. What are these factors of the network or the vehicles or the driver behavior that will affect emissions? And then you must have a model specification. Now, the model specification will be the relationship that you have between the independent variable and the dependent variable, in which case now the dependent variable will be the emissions. And then you create the DLL based on the variables and the specification that you have. But in this case, you must make sure that your variables are those parameters that can be generated by Vissim itself in the network. Then you run your simulation, analyze and visualize your results. So how can you do this in Vissim? If you go into the Vissim installation folder, you will have already files to start with, so you don't have to build your DLL from scratch. In the installation folder, in the API, there will be the .cpp file, the header file, and the project file, which you can easily say, oh wow, I can just have something to start from. You don't have to start from scratch in creating everything. So thanks to Lucas for making this available to users and making it available in the default installation folder. So we started from there, and then we make changes as we go on. So first we identify, brainstorming, what are the factors that will affect emission in Vissim? If you look, emission heavily depends on the vehicle operating mode. And the vehicle operating mode, if you look at it in Vissim, you would want to compare that to the psychophysical driver model or the states that are available in Vissim. You can be in any of the 5 states, either the free-flowing state, the car-following state, the approaching state, the braking state, or the collision state. Each state would generate a different type of emissions. If you are familiar with moves as an emission software, you know that the operating mode in moves is always about cruise, idling, braking, and then decelerating. And then after that, you need to make sure that your network is well calibrated in the Vissim model that you are working with. After the network, you want to look into your vehicle or fleet data. Why is this important? We generally understand that a vehicle with a mileage of 200,000 plus will have a different emission if you compare with a vehicle with a mile of 10,000 plus. So you want to, if you have this data, you can put it in your Vissim, and then you create a distribution for each type of vehicle category. The same way in your road network, you need to put in the information as much as you can get, including curvatures and gradients. I think Sol just talked earlier today about putting in gradient information in the network. This is pulled into the emission. And then after that, there is the speed, acceleration and deceleration. Now, you have to also make sure that as you are doing your network to get accurate and representative emission estimates, then your speed calibration must be what you have in the field, as we know that emission is quite speed intensively dependent. And then after that, there is the fuel type. Now, A number of vehicles use now gasoline and diesel fuel type, and each fuel type has a different emission rates. How would you put this in Vissim? You can have a distribution of the vehicle type. When you go to the distribution and then vehicle type, and then you also go to the 2D, 3D model vehicles, and then you can have a distribution of different vehicle types depending on the fuel that they are using, and then that can be pulled into your network for analysis. So today I'm going to use an example, and I give credit and acknowledge the University of Montreal in Canada. They did a study where they collected data and then identified factors that affect emissions, and calibrated the model and came up with the model specification. So the credit appropriately goes to them. The model was that relates the computation of CO2. So they calculated CO2 based on fuel consumption. So it had three components. The first component is it assumed that as fuel consumption goes up, the emission will go up. So there are two models here. There is the one for gasoline and then the one for diesel. So the one for diesel is related to fuel consumption by a factor of 26.5, and then gasoline by a factor of 23.6. Then after that, they estimated fuel consumption irrespective. We know fuel consumption is quite vehicle-specific, power-dependent, but this study estimated the fuel consumption as a sum of the drive resistance parameter, the rolling resistance parameter, the aerodynamic resistance parameter, and then the gravitational resistance parameter. So we have these estimates given. In the third component of this study, now here is where we get information that you can pull from Vissim, basically speed, mass, and acceleration. So you can see in the third equation, they give a clear way of estimating the driving resistance parameter, the rolling resistance parameter, the aerodynamic parameter, and then the gravitational resistance parameter. So we want to take these parameter estimates and then implement it in a DLL, and then link that DLL to our vehicle types within Vissim. So basically, we will do that beginning with the files that are available in Visual Studio platform, in which case you first will need to define every variable that you are using. Once you define the variables, you must appropriately ask Vissim to make this data available by returning it. And then after you ask Vissim to make this data available by returning it, you will then go into the .cpp file and then put in your model specification. As you can see here, we do that under CO2 emissions. So under CO2 emissions, you see first we give a condition using the if statement to choose which vehicle type. There is a vehicle type, in this case, the model that I was working with, type 200, type 201, type 210. And then there is a vehicle type, again, yeah, I can't see very clearly there. But then it's just, putting in the script that we had, the model specification that we had into the Visual Studio C++ script. And then after that, I also took care of deceleration, because we didn't want to get estimates of negative emissions. So we asked Vissim that if the acceleration is negative, then don't return that value. So we return 0. in this case. And then after that, you need to create the platform. Sometimes if you try building the DLL, you get the Win32 error type. That happens if you don't create the appropriate platform to build your solution. So once you create the appropriate platform to build your solution, it will be built in the debug folder if you had a debug folder, but you can change that to any other folder, of course. And then you just go to build solution. So that's where you, in the debug folder is just the folder name where I want the DLL to be saved. You can have any other folder name for that. So when you finally build your solution, you'll go to the build tab and then just run build solution, and if it's successfully done, you will see an indication at the bottom that one successfully built. If it's not built, it will tell you not built, and then you have to start troubleshooting the errors one by one. Of course, before I built it, I got a number of errors, especially if you don't identify your variable types appropriately. Yeah. So once the DLL is built, the next step will be, how do we apply that DLL in Vissim? I explained that if you go to the debug folder, that's the folder name I use, you will get the .dll API saved there. So I'm going to work with an example file which is available in our installation folders as well. It's a corridor with 6 signalized intersections completed in Texas, San Antonio. So in this use case, we are going to apply that to estimate CO2 emissions. So one, let's look at what are the parameters that you have to be cognizant about in the Vissim. One, you have to be aware of the weight distribution of the vehicles. If you have this information, you go to base data and make sure that you have the weight appropriately coded in with the right distribution, because the emission will pull randomly or stochastically the weights of each vehicle that gets into the network. And then after that, you want to be also aware of the acceleration functions by going to base data and then making sure that the acceleration information for the desired acceleration and maximum acceleration are appropriately coded in your network. You also want to make sure you have your desired speed distribution in your network appropriately coded, because these are the information that are emission intensive. And then after that, you need to go into vehicle type for each vehicle that you're working with, and under the special tab you will put the link for the emission DLL under the area that's highlighted in red. So once that is done and you just hit OK, you will then just run your simulation, and as the simulation runs, on the second column here, you will be able to see CO2 emissions being estimated based on the emissions model specification that we put in the DLL. So you can see the emissions are being estimated real as the simulation is going, every single simulation time step per time interval of evaluation that you identified in the model. So after that, you can then choose if you have any specific interest in a link that you are studying. You can have also a graphical display of the bar charts, as you see on the right side, that will compare. For example, in this case, we are comparing the CO2 emissions with the volume of the vehicles in the network. You can then also do a network hotspot visualization, where as the simulation runs, you will see your network changing. Of course, the way to do hotspot visualization, you have to activate your link evaluation, and then you will need to go to the type of link attribute that you want to be displayed as a hotspot, then under the link attributes, you have to choose emission as your link attribute. And when you choose emission as the link attribute and the rate at which you want it to be displayed, then you also choose the bar for the legend for the display, as you can see here as well. Then it will be able to, you know, simply show you where are the emission hotspots and what are the attributes that are responsible for the emission hotspot. And then the other part that people never look at, I would encourage you to also identify where are the emission low spots and what are the attributes for the emission low spots. Why is it different from the emission hotspots? So that's pretty much as easy as it is. And with doing this, you will be able to use the emission DLL, create an emission API, and then estimate emissions, and then it can be one of the MOEs when you want to do a project impact analysis of infrastructure development or road diet, for example. Yeah. So for this to work for you, you will need to have the emission module extension in Vissim. So if you try working on these and you don't have the emission module extension checked in your license, then it will not work and you will start getting concerned. So before you send a support request, check that you have the emission module activated for you. If you don't have it activated, then you can have that information on how you can have it activated. And that's as easy as it can get. So any question? Yeah. Okay.
Yeah. So actually, I have two questions. First one is, so this is done for links, right?
Yes.
Do you have plans sometimes in future to do second by second activity? And the second question is, your emissions are based on the fuel consumption, I guess, right? But the fuel consumption was not necessarily reported as an output.
Yeah, that's a good question. So basically, when we built the DLL, you remember fuel consumption is reported as attributes of vehicle parameters.
It's already there.
If you look at this here, fuel consumption in this number 2 is reported, where is this? Is reported as a function of the driving resistance parameter, the rolling resistance parameter, aerodynamic parameter, and then the gravitational resistance parameter. And then these parameters are a function of outputs that you get from Vissim, which is basically speed, mass, acceleration, coefficient of aerodynamics of frontal area, acceleration, and all that. So it's all connected together, and this is what we built in the DLL script. So we put in this script in DLL, then it pulls the information from Vissim, and then first estimates the coefficients, and then based on this study at the Montreal University in Canada, it sums up these parameters to get the fuel consumption. So fuel consumption is not given out as one of the, for this particular study. Yeah.
It can be.
It can be. Yep.
Given as an output, but right now it's not, right?
Yep.
That's what you're saying.
Yeah, now it's not. Yeah.
And the second question was, considering that this is for a link, do you have plans to have for individual vehicles based on their movements as they go through the network?
That's actually already available, because if you go to vehicle records and then you go to direct output and then you choose every vehicle type that you want, and then under that column on direct output you will go to attributes. It's normally bottom left. When you click on that attribute, then you can choose for that vehicle type emissions. And then you can choose which emission gas you want to be generated as an output. And then if you go to the .fzp file in your working directory, you will get the emission for every vehicle every time step.
So it's not for the link, it is a vehicle-based emission, correct?
It's yes.
it's not aggregation for the link. You can go into the details and extract second by second emissions for every single vehicle.
That's absolutely correct. Yeah.
That part I didn't understand.
Yeah, that's absolutely correct. Yes.
So have you done any comparisons between this model and moves with Vissim output?
That is in progress, and we are working on that now to try and compare these attributes with moves. But generally, we know that moves, we compared first the operating modes, and we understood that, okay, we have the operating modes in moves, also in Vissim. The difference between the Vissim and the moves one was the bins. You know, moves has about 41 bins based on speed. And there is the below 25, between 25 to 50, and then above 50, if you're familiar with moves. And then each has sub-bins. So that is just all about the way I'll go about doing that comparison is to have different speed distribution for each, comparable to each bin. But then we don't also have moves rates that can allow us to install the software. One powerful component of moves is that it has the I&M data, which Vissim doesn't have. So if we can get the I&M data for vehicle, which is quite state preservative, then we can do a direct comparison. But if you have the I&M data, then it's very easy to compare. So even if it's being compared, I don't think we are at a position where we can implement the I&M data in Vissim at this point in time. Yeah.
I just wanted to follow up with that conversation with Professor. So when you said there's already some attributes for different types of emission for at vehicle level, I know that one, but will that compute based on the Vissim's default calculation method or this method?
So this is just a typical example that we use as a use case to demonstrate how to implement the emission DLL. So it's not like owned by Vissim, no. So you may have to, get a model parameter with a specification, and then you implement that specification within the DLL using the example I gave. And then after that, you run that in your simulation, and you have to attach it to each vehicle type.
So then the vehicle type's individual fuel consumption would be based on my new DLL?
Absolutely.
Okay.
Yeah. Yeah, Mohammed.
So right now with the calibration, most people are interested in calibrating capacity and delay and things like that. Do you think if they want to have a model like that, like emission or safety, they need to calibrate the model differently based on trajectories of the vehicle rather than based on macroscopic measures? Because it may work from macroscopic measures, but then when you look at individual vehicles, acceleration, deceleration. So do you think that there will be additional, more detailed calibration needed to get realistic?
Do you want to take that, Lucas?
Well, yeah, I can say that we have had, again, from that big Japanese automotive manufacturer, we got some complaints because they were building their own emission DLL, and they found out that the trajectories of the vehicles were not what they expected. And that is mainly when coming to a standstill, approaching a signal, and so on. But that was like, 4 years ago or so, and then we added that smooth close-up functionality, and at least they were then content with the trajectories. So they said, now we can use it for our emission calculations and it's fine. So that's, in a way, might answer your question. We hope it is good enough now.